A famous 1950s surgical misadventure spurred much of our knowledge about memory formation. HM was a young man with seizures coming from his medial temporal lobes that led doctors to remove them both. The result was something much like the movie Memento, in which the protagonist can only recall a few minutes at a time. HM's memories before the surgery remained intact until his death, even though the physicians with whom he worked after the accident necessarily reintroduced themselves hundreds of times. The medial temporal lobes contain the hippocampus, a brain structure with an elaborate S-shaped curve that inspired imaginative pathologists to name it after the Greek for seahorse. Within the curves of the hippocampus are different neurons folded over on each other, working together to cement the foundations of new memories. While the role of the hippocampus in memory is well known, it is only part of a network that extends over practically the entire brain. Both very long and very short-term memories can exist quite well without the hippocampus and nearby structures, as evidenced by some of HM's retained abilities. Without the hippocampus and related structures, however, most new memories cannot last. The hippocampus does not work alone, but as part of a neural network, well studied by medical students, called the pathologists circuit. This includes the hippocampus, mammillary bodies, two small structures near the brainstem, parts of the thalamus, and the cingulate cortex. Other parts of the brain, such as the basal forebrain, play a role in memory. The basal forebrain sends acetylcholine to the cerebral cortex. These projections are damaged in Alzheimer's disease. Medications such as Aricept work by increasing acetylcholine levels.